Well, it is 6 p.m. and this community has suffered a power outage. It's raining right now. The house I live in has no power, no lights, and I couldn't even heat myself a hot meal. This power outage could last for a while, and I thought I would make an impromptu video. But fear not, for I have two electric vehicles. One is capable of vehicle to load, or V2L, and another one that is not capable of vehicle to load. Now let me show you how you can use your EV to get through a power outage. For those of you who are new to our channel, I live in Bella Bella currently. This is a very small town. In fact, it's a First Nations reserve on the central coast on the west side of British Columbia. So if you're interested, you can look on Google Maps and see where it is. Bella Bella, B-E-L-L-A, B-E-L-L-A. So power outage is not something that happens too often here, but since I've been here, there's been one other instance of power outage. So a lot of households here have generators. So I don't know if you can hear this right now, but an adjacent house has a generator. It's pretty loud, and that's one of the main disadvantages to a generator. The other one being, you know, you're burning gas. So what am I gonna do? I don't have a generator at all, but I have two electric vehicles. The first vehicle I have with me is the Mitsubishi Outlander plug-in hybrid electric vehicle. So this is the 2023 version, and it has a very special capability for our situation right now. It has vehicle to load. What that means is it has 120 volt outlets. I'm going to plug in an extension cord to this vehicle and run it into the house, and then power some appliances and devices inside the house. The second vehicle I have with me is the Hyundai Kona Electric 2020. Longtime viewers of the channel are going to be fairly familiar with this vehicle. Now, the Kona Electric does not have V2L capability, but that does not mean it is not helpful in a situation just like this. I'm going to show you what you can do with a vehicle like this to help you in a power outage situation. Welcome to the trunk section of the Outlander PHEV. Now here's the plan. What I'm going to do is I will run a extension cord from this 120 volt outlet out through one of the rear door windows, and then right through this window into the house. So this is how I am planning on powering some devices and appliances inside the house with the vehicle itself. Now, in terms of specification, the 120 volt outlet on the Outlander PHEV can only supply up to 1,500 watts. So that's 1.5 kilowatts. It's not the full 1.8 kilowatts that the typical household outlet can supply. So as long as the entire usage, power usage of devices that I'm using inside the house is under this power limit, then the vehicle should be able to supply it just fine. The Outlander PHEV currently has around 60% battery, so the entire battery of this vehicle is 20 kilowatt hours. So 60%, it's about 12 kilowatt hours. Now, 12 kilowatt hours of battery is not a lot for a vehicle that's driving, but it's actually a fair bit if you're just using household appliances. This will definitely get me through the night. All right, I have successfully brought power into the house. So let's follow the extension cord. So it is, of course, plugged into the vehicle, and this goes all the way to the window of the door. So it goes all the way up here to the window of the car door, and it trails here and all the way up into this gap I have created in the window. So now the extension cord is inside, and we have power. Now that we have great power, what about great responsibility? Or rather, what kind of appliances do I want to run inside the house? Well, to start off, I definitely want to run my fridge. I won't plug it in during the evening when I'm still up and about, but I'm definitely going to plug it in right before I go to bed. So that way, none of my food spoils. Other things I want to run include cooking appliances. So I want to keep my water dispenser running. So this is something that will keep water warm so that I always have hot water to drink. I will also like to run my microwave so I can at least heat up some hot dinner. Other things I want to run are things like my laptop and also access to internet. That's something pretty interesting, and I have Elon Musk to thank for that. All right, I am inside the house, and what you guys can see is probably pitch darkness. So let there be light. Aha! Here we are. This is what I call success. So this is the front foyer of the house, and here I have set up a little couch for myself. And this is the extension cord that ran through from outside from the Outlander PHEV. Now I have a couple of old t-shirts to block the section of the window that is open. It's pretty cold outside, and I want to keep out the cold air, add a little insulation. So this extension cord is pretty long, so I can pull this to many different places in the house. And I have a power bar. So the only thing plugged in is this lamp. It's only the beginning. First order of business, dinner. I'm gonna heat up some pasta and then I'm gonna eat. I'm getting hungry setting up all this stuff. Before I start the microwave, I just want to show you that I am monitoring the power draw on the Outlander PHEV using this OBD app. So this is connected via Bluetooth to a OBD dongle that is connected to the vehicle itself. As you can see right now, the high voltage battery is drawing basically 400, 300 watts. I'm pretty sure that once I turn the microwave on, this number is going to go up. Okay, the pasta is in there. Let's heat this up. I'm hungry. But I always practice safe microwaving, I guess. So I'm going to put a cover on it so that it doesn't explode all over the inside of the microwave, and I have to clean it up. So let's close that up. Now this microwave is rated for 1.15 kilowatts, so 1,150 watts, which should be under the limit of the vehicle itself, which is 1,500 watts. This lamp, it doesn't use much. This lamp is a 40-watt lamp, so that is negligible. I want to see when I turn on the microwave what kind of power draw we're getting. So if it's 1.15, then we'll probably be drawing around 1.5 kilowatts. So let's see if that happens. Oh, power draw's going up. Okay, 1.5, 1.6 kilowatts. So yeah, like I said, this microwave was rated for 1.15 kilowatts. So before we started microwave, consistent power draw was around 0.4, 0.3. So add that to 1.15. Yeah, this is about what you would get. Okay, let's heat up some dinner and let's move on to the next order of business. Next order of business is something to drink. Now that I have something to eat, I need something to drink. So let's make some tea. This is a water dispenser. And for those of you who had not had the pleasure of using one of these, it is a device that heats your water to the perfect temperature for making tea and keeps it warm. So this device is rated at 928 watts. So again, within the power limits that the Outlander PHEV can supply. It is not plugged in right now. I'm going to plug it in and see how much power it draws. Okay. All right. It should start heating slowly. The water dispenser is not a very fast powering up device. So, oh, there it is. Yep, that's about 900 something watts. So let's heat up water and make some tea. And the water is hot and ready for tea. So It's always very nice to have water ready to go and be able to make tea at a moment's notice. Very nice. Ah, nice hot cup of tea. Ah, wow. Now that we had our tea, time to surf the web. Now, how do I get internet when there's a power outage? Well, as I said, I have Elon Musk to thank for this. Now, for those of you who know, you already know what this is. This is a Starlink router. This is the second generation one. And of course, I have a Starlink satellite dish outside. Let's plug this in. I'm not 100% sure how much power this uses. I think it should be under 100 watts. So let's plug it in and see how much power it draws. Let's see. Okay, our Starlink is working. So as you can see, it is online. So we got internet. I couldn't really tell how much power it's using. It's probably such a small amount that it doesn't really register. It's just part of the natural, normal fluctuation. Now, to prove that internet works, let's do a speed test. Ooh, that is not bad. 70 megabits. Oh, 80. That's download. What's upload? Upload is 23, 25. Okay, so 80 megabit per second down and then about 19 megabit per second up. So that's pretty good. We have internet. Last but not least, I would like to power the fridge with the Outlander plug-in hybrid. Now, normally the fridge is plugged in the back right here, but because we're in a power outage situation, the fridge is off. Now I can open the door and confirm that there's no light. It's not working. I am curious to see how much power this fridge would draw, because the documentation on this particular fridge is a little bit scarce. It's an old fridge, so I don't actually know how much power it draws. From what I gather, it might be around 700 watts. So we're gonna plug it in and let's see how much power it draws. Okay, it works. Now, in terms of the increase in power consumption, it is maybe 150 to 200 watts. Because baseline is 0.3, 0.4, now it's around 0.5, so maybe 200 watts right now. And to confirm that the fridge is working, let's open the door. Aha! There is light. At this power draw, which is, let's say, around 200 watts, yeah, the vehicle can definitely power this fridge for a very long time. Remember, the power draw is around 200 watts, and we're at 60% battery. 60% battery on a 20 kilowatt hour battery, it's around 12 kilowatt hours. So that's actually a lot of power, a lot of juice for the fridge. I'm definitely going to be fine leaving this plugged in overnight. Okay, I'm actually quite comfortable here. I'm glad the Outlander PHEV was able to provide me with all the electricity I need to stay nice and content for the evening. I would like to talk to you about what you can do with an EV, like the Kona Electric, that does not have V2L capability during the blackout, because even though it does not have a household outlet, it could still be very useful. I realized that I should probably shoot this next part when there's some daylight, because if I go in the car and show you stuff right now, you're not going to see anything. So let's transition to the Kona Electric when there's some daylight. Now that it is daytime, let me show you how you can use an EV like this, an EV without V2L capability, to help you out during a blackout. One of the simplest things you can use your EV for during a blackout is as a climate-controlled room. Now, if it's too cold outside or too hot outside, you can simply turn on your climate control and heat the interior or cool the interior. As long as you have a vehicle like the Kona Electric, that is a battery electric vehicle or BEV, whenever you are using climate control, there will be no exhaust. This electric vehicle, the Hyundai Kona Electric 2020, does not have V2L, or vehicle to load. This is the ability to output power through a 120-volt household outlet. The Outlander PHEV has that ability, but this vehicle does not have it. But there are also many other ways to draw power out of this vehicle when you have no other sources of power. Let's start with the very basics. Now, all modern vehicles should come with USB ports, and that includes all EVs. As long as you have USB ports, you can keep your most prized possession alive, and that's your phone. For a lot of people, the phone is your primary way of communication and entertainment. If you want to call family, friends, or text them for the younger generations, you're gonna need your phone topped up. And as long as you have some kind of a charging cable, you're able to keep your phone charged. A lot of vehicles, like the Kona Electric, also comes with a wireless charger. Outside of phones, what else could a USB port charge? Well, it's limited to small electronics, unfortunately. Once you move beyond devices like phones and tablets, a lot of these USB ports are not going to be powerful enough. One of the most powerful USB ports in an EV is probably on the Teslas, specifically the Model 3 2023. The USB port, if you're only using one of them, has a maximum power output of 42 watts. And that is quite a lot for a USB port. That can potentially charge some very low power laptops like the MacBook Air, which ships with a 30-watt charger. But for the vast majority of EVs out there, your USB ports are not that powerful. For my Kona Electric, the most powerful USB port is going to supply 5 volts at 2.1 amps. So that's only up to 10 watts. Given that the vast majority of laptops you can get, especially more powerful laptops, are going to need at least 60 watts to even start charging. So outside of small electronics, your USB port will be unable to power anything bigger than a phone or a tablet. Let's step it up to the next way you can draw power out of your EV, the 12-volt outlet. The 12-volt outlet is also traditionally known as the cigarette lighter plug, and it is infinitely flexible. There are many accessories that you can buy which runs directly off of this outlet. Things such as phone chargers, heated blankets, coolers, you name it. There are a lot of accessories that runs off of this specific plug. But the most flexible way of pulling power out of your 12-volt plug is by using something like this, an inverter. For those of you who don't know, an inverter is a device that converts 12-volt DC power into 120-volt AC power. With such a device, you are able to power many more electronic devices that typically runs off of your household outlet. The Kona's 12-volt outlet supports up to 180 watts of power output. So as long as the devices I am powering is below that limit, 180 watts, I should be fine. Devices like laptops, e-bikes, lamps, and electric toothbrush. Any device that don't draw too much power but cannot be powered via USB can be powered by a 12-volt outlet through an inverter. Let's step this up one more notch and go under the hood. The inverter, fortunately, can be used in another way. A lot of inverters allow you to directly connect it to the 12-volt battery via alligator clamps. This bypasses the internal 12-volt plug and its power limits. However, I just want to say, only do this when you know what you're doing. Connecting your inverter directly to 12-volt battery has some risks. For example, you can create sparks. If you're using it in wet or rainy conditions, something can short circuit. And if you draw too much power or you draw power for too long, you can actually kill your 12-volt battery, and then you won't be able to turn on your vehicle anymore. So please, only do this at your own risk. The inverter that I have is a 400-watt inverter. So that means it's actually a little bit wimpy. It's not that powerful. Many household devices that people would like to power, such as kettles or coffee makers, microwaves or toasters, they all draw about 900 to 1,000 watts. So this is not going to be enough to power those devices. For a vehicle like the Kona Electric, you are granted direct access to the 12-volt battery, which means you can actually connect your inverter directly to the positive and negative terminals of the battery. This is not the case for every EV. In fact, a lot of EVs hide the 12-volt battery, and the terminals are connected through the 12-volt circuitry inside the vehicle. If you cannot directly connect to the terminals of the 12-volt battery, then you are subject to a current limit, and this limit is usually guarded by a fuse. Now, if I was to go through the 12-volt circuitry of the Kona, then I will be going through a 10-amp fuse. Fortunately, I am connected directly to the terminals on the 12-volt battery, bypassing the circuitry within the vehicle. So that means I can draw more power than what this 10-amp fuse will allow. Now, just what can you power with an inverter like this? A not super powerful 400-watt inverter. Let's say you're in a blackout situation and you want to watch some TV. Well, that's exactly what I'm going to do. I'm going to power a TV with this inverter. So the TV that I have in the house, has a maximum power draw of 155 watts, which should totally be fine being powered by this. So I have a very long extension cord running from the inverter all the way inside the house. And let me show you my blackout setup. It's a very long extension cord. There's the TV. So I got a remote and just want to show you that it is not turning on. No way, because it's been unplugged. And here is the plug for a TV and the extension cord. I'm gonna put those two together. Okay, the TV is plugged in and we should be able to turn it on right now. Okay. See, TV is on, and we are able to watch one of our own YouTube videos. There we go. The TV works. We're enjoying nice entertainment, all thanks to the inverter. Whichever method you're using, whether it is through the USB port, the 12-volt outlet inside your vehicle, or directly from the 12-volt battery, you should always keep your vehicle on. When your vehicle is on, the onboard DC to DC converter is constantly charging your 12-volt battery from the main traction battery. If you have your vehicle off and you're pulling power from the 12-volt battery, you may drain the 12-volt battery. If your 12-volt battery is dead, then you will no longer be able to turn on your vehicle. Well, thank you so much for watching this video. I hope you learned a lot of useful things. And if you like what we do, make sure you like and subscribe to our channel for more electric vehicle content. My name is Solomon, and we'll see you on the next one.